Okay, 6. We need to simplify. So now we're still doing all of the exponent rules. There's just more involved, okay? They're more complicated. So let's do 6a. Okay, so right now, are my bases all the same? Are my bases all the same? If I don't see an exponent, is there an exponent there?
Yes,
1, right? So I can shove that in there so I feel more comfortable. So all of these brackets are telling me what math operation am I doing? Multiply. So when I multiply, what do I do with my exponents?
Use add.
Yeah, add, thank you. So all I'm doing is 2 plus 2 plus 1. That's it. So my final solution here is x to the 5th. I cannot evaluate these questions because I have an unknown variable. This is as small as I can get it. Yeah, if the question said like x equals 3, then you could plug it in. All right, B. Do B next, guys. Okay, so I have a squared x cubed bracket 4ax squared. First things first, I'm going to throw a 1 on that a as an exponent just so I don't forget about it. And this is not a big deal because I'm going to think of things differently. 4 is a number, it's one thing. A is a letter and it's A, that's one thing. And then X is another letter, that's another. So what I'm going to do is I'm going to group everything. This is all multiplication, so I can rearrange things and it's not going to change the question. So I'm going to go 4 and then I'm going to stick my A's together. And then I'm going to put my X's together. Is everyone okay with that? Does the 4 have a partner of any sort? No, so it just stays 4. Again, I'm going to show this step of me adding my exponents, and it is up to you whether or not you do that on your question, but it can get you part marks if you have messed up somewhere along the way, okay? 3 and x to the 5th, okay? So I've just added my exponents now. Is everyone comfortable with this? Okay, let's do C. Okay, I have a quick question. What is does 2 have an exponent in the bottom there? Does 2 have an exponent? What is it? 1, perfect. Okay, so I'm going to plug 1 in here. The reason that matters is, do you agree that I have a power of a power right now? Okay, I have a power of power, which means it multiplies by the exponent. When you have a number like this, you need to make sure that that multiplies all of them. Okay, that both exponents get multiplied. So if you forget that there's a 1 on that 2, you're going to be missing part of the question. So now it's 1 over 2, 1 times 3, right? And a 4 times 3. Again, you don't need to show that step if you don't want, but I'm just doing it so we know where it's coming from. So I get 1 over 2 to the 3, a to the 12, right? That doesn't look like 12, so I'm going to erase and fix this. Okay, now, would I ever leave that 2 to the 3? What is 2 to the 3? 8? Right? Everyone agrees with that? So my answer is going to be 1 over 8a to the 12. Everyone happy with that one? We're going to talk about negative exponents in a little bit, and it'll change things slightly, but we'll wait till we get there. D, I'm not done. Okay, so D. D is C to the 3, B to the 4 over C, and I'm going to add that exponent of 1 there, and B squared. So now, because this is a division, I do what with my exponents? Subtract. So I get C3 minus 1 and D4 minus 2, which gives me C squared, B squared, and I'm done. You have done this before. Does it make sense, Stephen? You're good? Damar, you're good? Wow, this is crazy with only 2 of you here. Okay. 0 and negative exponent. Again, on your right-hand side. If you look at the 0 exponent, it's right down on the very bottom of the exponent laws. X to 0, anything to 0 becomes 1. Okay? They'll all equal 1, unless we need to watch with the negatives in a second, but yes. So in this case, 5 to the 0, 1. Okay. Yes, this one, that negative's not actually attached to the 3, it's out front, so I need to write it. And then 3 to the 0 is 1. Okay? This one, that negative is attached to the 6. Everyone agree with that? So my answer is just 1. And 0 to the 0, right? I know this is counterintuitive. Is what? Try it. You get an error. Error, okay? So we're going to say does not exist. Okay? Does not exist. You can never actually have a base of 0. You can never have a base of 0. Okay? You can get really close. You can have a really tiny decimal, but it'll never be 0. Okay, next, negative exponents. So the hint is here, or you can look at the board here. What happens with negative exponents is that if your exponent is negative, everyone agrees that a number always has a 1 as a denominator, even though you don't see it. So what happens is, if that negative exponent, what you can do is flip it. Yeah, the reciprocal. The reciprocal will make it positive, and vice versa. If you have a negative in the denominator, you can flip it again. Now, you are only flipping the variable with the negative exponent. If one of the variables has a positive exponent, it stays up top, and you only move that negative exponent down. Okay? So, I'm going to come in here. So if I want to create this, again, it's always over 1. As soon as I flip it, it becomes positive. And evaluate. So I don't know if I'm going to have enough space here, but that's easy because 5 to the exponent 1 is 5. Right? Next one over here. Again, that's always over 1. So you flip it, which becomes 1 over 9. Pardon? Is this making sense though? Okay. Stephen, you're good? Okay. Again, this is always over 1, so it becomes 1 over 6 cubed, which is 1 over 216. Okay. Now I'm going to break this one up a little bit. I'm coming over here to give myself some more space. Do you agree that when I have this, it actually means that this negative 2 comes here and this negative 2 comes here, like both of them? So as soon as I flip it, they'll both become. So it'll become 3 squared over 1 squared. That doesn't really matter because it becomes 9 over 1, which is just 9. Everyone agree with that? Sorry, my notes are all over the place. I should have spaced these slides out better. We're good? And that's it for this one.